Let's talk about PACE because this is very exciting. Another satellite. So can you tell me what PACE stands for and what makes this satellite different?
So PACE stands for Plankton, Aerosol, Clouds, Ocean Ecosystem, and it's NASA's newest Earth observing mission. For difference than everything else, PACE will give us a new and really like a rainbow full view of the oceans and atmosphere. NASA Earth satellites have been observing Earth for 20 years, and they've given us so much, especially from the ocean. But theoretically, it's a retro technology. We need this new technology to be able to answer the questions that have accumulated during that time. Questions about atmosphere, questions about, oceans, and also questions about just global ocean climate, global Earth climate.
Yeah, it's kind of interesting the fact that this is going up into space, and space feels like this unexplored place, but really the ocean is this unexplored place, right? Can you tell me a little bit about what we have to learn here that's still so new?
Yeah, that's correct. I mean, oceans are completely unexplored. We all want to go to Mars, but we have things to do here, and that's what I'm doing there. That's why we're building PACE. If you think about it, you think about ocean as a one big thing. It's blue. No, ocean has ecosystems. Ocean has its own jungles. Ocean has its own deserts. Ocean has its own meadows. And currently, we can see this teeny tiny phytoplankton from space that they are the food base of that food web in all these ecosystems of oceans, just as a green. I don't know if it's a jungle. I don't know if it's a meadow. I don't know what it is. PACE will be able to see that. PACE will give us the spectral resolution to be able, to say, oh, look, these are the roses of the ocean. Oh, look, this is the jungle of the ocean with some papayas growing inside. Things like that. We're going to be able to see this diversity, which is ultimately crucial for understanding how we're going to be able to predict fisheries. Do we have harmful algal blooms on our beaches? Or how is ocean controlling our climates?
Yeah, and you mentioned algal blooms, and they kind of really came into the forefront in the past couple of years, making news. Is this going to help us better understand, predict, and prevent that from happening?
Exactly. So PACE will be collecting this information, and due to the spectral resolution, is going to be able to distinguish different types of phytoplankton, including some of the harmful algal blooms. And the important thing about harmful algal blooms is to be able to detect them early on. And so we're hoping that we're going to be able to do that. Furthermore, we have been working with, people who are there in the field. So like water quality managers, local scientists, to be able to use our data to use it for their prediction stuff. And ultimately having this continuous data from space, this global data from space, accumulating that, we're going to get this body of knowledge that's going to be able allow us to predict and hopefully prevent in certain situations.
I saw something about it's going to map the color of the ocean. Can you explain what that means? Because I don't know anything about the color of the ocean, other than it's blue.
Exactly, yeah. And then you need to start with the majority of the ocean is blue. But then, you go somewhere to the beach, and then it's really not that blue anymore because there's things in it. And if you go to the beach and instead of, the beautiful sand where it suspends, it kind of gets brownish because there's sand in it. And then if you go close to the river mouth in Chesapeake Bay, kind of gets brownish because there's dead leaves, they're oozing their tea in there. And if you go somewhere else, it gets reddish because there's probably phytoplankton that is red. Phytoplankton comes in different color shapes and sizes, and all these things modify the color of the ocean. And there's certain situations where you and I are not going to be able to see that with our eyes. OCI, Ocean Color Instrument, on top of PACE will be able to detect that. So by looking at the changes in the color of the ocean, we're going to use this fancy mathematical formula to tell you, oh, there's a little bit of sediment there. Oh, there's a nasty algae. Don't go there. Or oh, look, it's a beautiful bloom in the North Atlantic. Springtime is here. That's what PACE is going to give us, just using the ocean color.
How deep can it look into the ocean? Because I know deep ocean exploration is this very unknown world too. So how deep are you looking here?
We're actually looking just as a little bit of a surface ocean. But you have to understand a teeny tiny bit of a surface of the ocean where the phytoplankton lives, where the light is the thing that feeds the rest of the ocean. So as this phytoplankton dies, as they're feeding different creatures in the ocean, all that carbon through, different things that they produced kind of falls down and feeds majority of the rest of the ocean. As these things, that phytoplankton falls down, they kind of the low creatures of the deep ocean, they come and nibble and eat that. So pretty much you have this amazing factory on top that is feeding the rest of the ocean. And that's what we're going to be able to see. Not what's happening down there, but we have models, and these models are going to be feeding on PACE data, allowing us to better understand the processes in the deeper ocean as well.
So very similar to weather satellite. This one I know focuses on ocean, but there is some atmospheric interaction here with PACE as well, right?
Yeah, there's a really important, like the whole second portion of PACE, and PACE's mission is to look at the atmosphere. Atmosphere doesn't have like ecosystems, but they have things happening in there. You have these teeny tiny particles called aerosols. They can come, from like wildfires. They come from smog, volcano deposition, sand coming from Sahara Desert. And they interact with water in the atmosphere and they make clouds. And this interaction between the aerosols and water cycle and this making of the clouds is one of our biggest unknowns. This is one of the things that we really don't understand well when it comes to climate, how climate works in our planet Earth. So having ocean color instrument and 2 additional polarimeters in PACE, which are 2 additional instruments, we're going to be able to discern different types of aerosol and really focus on this interaction between the aerosols and clouds to be able to better understand our climate.
So when it comes to wildfires, is it similar to algal blooms where the more information you have on it, we might be able to better handle it or even prevent it?
I mean, we hope that eventually knowledge that NASA is collecting, not just with PACE, but other Earth satellites, is going to help with the prevention. Like knowledge is the key. And with that, we're really hoping that PACE and knowledge and understanding of PACE is going to allow us to better track the plumes coming out of these fires and maybe how do they deposit in the sea and how they can, talking to the oceanic creatures. But ultimately, we're giving this data freely to everyone, scientists, meteorologists, water quality managers, forest managers, and hopefully it's going to be ultimately to them to use this information to be able to find way to prevent these forest fires.
In addition to that, can you think of any other ways that like the general public should care about PACE and how it might impact their daily lives?
Yeah, well, I mean, like you have on one side, we just spoke about air quality. Anywhere in the world, air quality is a problem. Not maybe today, but maybe it was last summer. It's going to be happening, this winter. On the other side, I mean, you might don't like to eat fish. I'm a sushi girl. Like I love eating fish, but you have to understand that fish and fisheries is a big source of protein. Understanding how the protein indirectly or directly affect us and that we depend on it is really important. And that's what PACE is going to help. It's going to allow, not specifically NASA, we don't do fisheries, but our sister agencies like NOAA and all around the world to use this information to be able to predict fisheries yield, to help the aquaculture people. And that ultimately just going to help you understand things so we don't have an economic impact if some kind of fisheries dies or something bad happens. So it's all interlinked, we're Earth is system. It's our only home that we have. We might don't care about ocean and stuff, but it impacts you. And this is where PACE comes to play to, help you better understand and see our planet in all its colors.
I know it's being launched tomorrow. So does it start working right away? Take me through the logistics. Does it go up and immediately start feeding back information?
So I think once it launches, it calls back and says oh, I'm cool. I'm okay. And then it pretty much, goes back to engineers. I'm a scientist, so I'll explain how it works in my head. So engineers say, okay, are you working? I'm working. So testing all the different little parts. And they do that for some kind of 60 days. And after 60 days, that's a commission period. The data starts coming towards us, the scientists. And this is where we start playing with data. We're going to look at the data if it's okay. We're going to use some calibration and validation data to make it as perfect as possible and start sharing it with the whole world. NASA shares its Earth data freely. So that's what we're going to be doing with PACE. So yeah, hopefully 60 days we get the data, 90 days you get the data, something like that. But yeah, really looking forward to it.
That's a good turnaround. I know you've worked on PACE. Are you working on any other projects? Anything else we should be looking for out of your research over the next few years?
PACE, this portion, the satellite that we're talking about is just one of the components. Once we launch satellite, we have to really be sure that it's working okay. So there's a validation and calibration portion. But also, in order to be able to use the data from PACE, what I told you, the story about ocean color, and then we have mathematical formulas. We have some mathematical formula, but the thing is, PACE is something we never had before, so we have to develop new ones. So after PACE gets launched, we're going to have a large number of field calibration validation campaigns, both in the air from the aircraft and both in the ocean, trying to collect data to make sure the PACE is working as it should be, but also using the data to share it with all the scientists to start building new mathematical formulas, new algorithms to detect new things using PACE data. So once we launch, there's going to be lots of work in PACE, and then it's going to be off to the field to collect more data to validate PACE. So it's going to be a busy few years.
Hey, thank you so much for watching. While you're here, check out some other videos you just may like.